Wave speed. Physical Sciences, Grade 10. Speed. All moving objects have speed. Imagine if a snail was racing Sonic the Hedgehog. Let's say this was a 100-meter race. Who do you think will cross the finish line first? The snail or Sonic? And give a reason for your answer. Well, in this instance, we know almost intuitively that Sonic will cross the finish line first because he runs very fast. This means that during the race, he will have high speed. Therefore, Sonic will run 100 meters in a very short time. The snail, on the other hand, will cross the finish line last and after a very long time because it moves very slow. This means during the race, the snail will have very low speed. Remember, in the beginning, I said all moving objects have speed. Waves are moving, meaning they have speed, something called wave speed. At the end of this lesson, you will be able to define wave speed and use the wave equation to solve problems involving waves. For this video, you need to understand concepts such as frequency and wavelength of a transverse wave, which were defined on the previous video. Here is a diagram of a transverse wave moving from left to right. This wave has speed, which is the distance a wave travels per unit time, or the distance traveled by a point on a wave per unit time. From this definition, we can understand that there's a relationship between wave speed, the distance traveled, and the time it takes to travel that distance. This relationship is expressed by what we call the wave equation. The wave equation tells us that the speed of the wave represented by v equals the product of the frequency f and the wavelength lambda of a transverse wave. The speed is measured in meters per second, the wavelength is measured in meters, and the frequency is measured in hertz. Let's solve a problem involving the wave equation. When a string is vibrated at a frequency of 5 Hz, a transverse wave of 0.5 meter wavelength is produced. Determine the speed of the wave as it travels along the string. We can first draw a diagram representing the transverse wave like this. The transverse wave is moving from left to right at a speed we must calculate. The wavelength is just the distance between two points that are in phase, or the distance between two consecutive crests, and that distance is 0.5 meters. The frequency is given as 5 Hz. To solve this problem, we know that the frequency is 5 Hz and the wavelength is 0.5 meters. What we do not know is the speed of the transverse wave, but we know we must calculate it in meters per second. The second thing is to find an expression that relates all these three quantities together, an equation that links the wave speed to the frequency and the wavelength of a wave. And we know that expression to be the wave equation. We do not need to convert any of the given quantities or rearrange the terms, so we just substitute the known values of the frequency and the wavelength. We calculate the wave speed to be 5 multiplied by 0.5, which is equals to 2.5 meters per second. Therefore, the frequency, the wave travels at 2.5 meters per second along the string. We have said that the wave speed is given by the speed v equals to the frequency f multiplied by the wavelength lambda. Let's call this equation 1. In the last video on period and frequency, I mentioned that the frequency is related to the period of a wave through the following equation. F equals to 1 divided by t. Let's call this equation 2. You can see that we can substitute F into equation 1. What we do that we are left with V for the speed equals to, when we do that, we are left with V for the speed equals to brackets 1 divided by T bracket all multiplied by the wavelength lambda. 1 multiplied by lambda is just lambda, and T multiplied by 1 is just F. So in the end, our equation becomes the wave our equation becomes the wave speed equals to the wavelength lambda divided by the capital letter T for the period. In instances where you are not provided with the equation with the frequency but the period, you can use this variation of the wave equation. We have come to the end of this lesson. At this point, you should be able to define the wave speed as the distance a wave travels per unit time, or the distance traveled by a point on a wave per unit time, given by V equals to frequency F multiplied by the wavelength, or the wave speed equals to V equals to the wavelength divided by the period, capital letter T, and this is measured in meters per second. In the next video, we are going to look at a previous question paper so that we can learn how to go about solving problems involving transverse pulses, transverse waves, frequency, period, and all of these topics that we covered in the previous videos.